It was a great presentation. Thank you very much. And as we are going further and further in Europe, really international, I'm greeting our friends in Netherlands. Hi, Owen. Hi, Daniel. Let me
Hello.
introduce, hi guys. Let me introduce these two gentlemen who are working for AAEON Technology company. Owen is a marketing and BDM manager for Europe, and Daniel is a software architect at AAEON Europe. The topic is very, very interesting, and not easy one. It sounds how to expedite robotic development. The robotic development, artificial intelligence, and anything around robotic is gaining on importance these days. And our two presenters today will show you how you can expedite your robotic development in general. Before we start and dive into the presentation, let me ask you a question. This one is for Owen specifically. So we are normally working with ecosystem partners to build artificial intelligence and IoT hardware. Can you describe what can we imagine? What does it take and what is behind all this? Thank you.
Yeah, sure. Thanks for the introduction. And today we are happy to join the DEBATECH conference. So let me take the first question. So AAEON, as far as you know, I think it's the hardware manufacturer. While we discover more and more customers are looking for solution that is validated and integrated with the essential software components or even the hardware components to build the whole solution. So that it could help them to shorten the development cycle and reduce time to market. Then that's why AAEON start to find different partners within AI and IoT ecosystem. The first step, we work with Nvidia and Intel to enable essential toolkits or frameworks for different applications development. For example, like Intel OpenVINO for AI, Intel RealSense SDK for 3D vision or mapping in AMR application as an inference, or Nvidia ISAC SDK, which we will talk later in our slides for AI or robotic related applications. Then with the foundation we built from that step, we then find different independent software partners or vendors to build their applications on top of our platform and bring this to customer that is looking for applications level offerings, such as quality inspection, smart surveillance, or AMR, etc.
Thank you. Handing over to you guys.
Okay, I'm Owen Wei, and together with my colleague Daniela, we are happy to join DEBATECH conference together today. Then we are going to share our expertise and AAEON's autonomous mobile robot solutions. So first, let me cut in from a market perspective to give you a background of how AMR market will be in the future. So AMR market size stood at 1.67 billion in 2020, and it is expected to reach 8.7 billion in 2028, with an annual growth rate of 23.7%. So why AMR grows so rapidly? What factor plays important role here? The growth of e-commerce has always been a key factor that boosts the growth of AMR due to high labor demand in distribution center to address the booming number of the orders. And the COVID-19 also gives a hint on e-commerce as people couldn't go out for travel, so that they have more time and money to browse and purchase items through internet. And the pandemic also makes situation of lacking workforce even severe. Therefore, implementing AMR seems to be the optimal option for company to stay productivity, not only for current situation, but also for the future. So now we know what's behind to push AMR. Now I'm gonna talk about the benefits it could bring. I just named a few here. So for example, not many people would like to take night shift, so that employer would need to pay more to ensure continuous operation. But with the help of AMR, employer could then reduce labor cost and avoid workforce shortage. Besides, AMR is operating through accurate algorithms so that it can keep consistency and avoid mistakes even after long working hours. Thus, combined with a non-stop operation, it can increase productivity. Besides, the AMR is linked to the warehouse management system so that every step is recorded for traceability. And the AMR could move around the production line or warehouse so that it gives high flexibility in the layout of either warehouse or factory. I will talk more about this in later slides. So as you can see here, there are many benefits of AMR. So in these slides, I would like to showcase some possible applications which can be achieved by AMR. You could see there are different AMR for variable applications in factory or warehouse scenario. In the command center or on production line, few employees are working with a human-machine interface. Normally, it's like a tablet or the touch panel to ensure everything works well and check on real-time operating data. Then in the production or packing or delivery area, there are AMRs designed for different specific purpose. For example, there are equipment maintenance robots for regular maintenance tasks. And there is sorting robot to sort the right package, or material handling robot to execute goods to person task so that it could reduce the time employees spend to get the exact item and increase efficiency. Or there is a robot that could help to automate the inventory management process. Through the evaluation of AMR robotic technology, there will be more and more interesting applications in the market that users could leverage to enhance the efficiency and automate their process in the production site. And in these slides, I would like to talk more about how AMR could evolve the assembly line. When AMR is each station within the production line, it could give the flexibility and the scalability. For example, after a certain station within the production line, you would probably need to do like an additional QC test while you don't want to move all the equipment here. Then the flexibility of AMR could allow you to just move this section to the QC department without too much hassle. Or you would like to add additional stations for different tasks, you could also achieve through the scalability of AMR. Thus, the AMR gives the interoperability with other departments, like you could directly move the finished goods to warehouse right after the process, then arrange for packing and delivery. So you have heard about the good points of AMR. But we all know it ain't easy to develop one by ourselves. A solid robot will require many components to work seamlessly to function properly. In such case, select right hardware components and the integration with the software stack have been extremely important. So how AAEON helps to solve these pain points? Let's take a look from the bottom to top. First, AAEON is hardware manufacturer, like I mentioned at the beginning, to provide options for different computing platforms. The most popular two are Intel and Nvidia. Then, like I mentioned, only one part, only hardware parts like computing unit is not enough. We would also need like a robotic SDK and essential components to have a seamless integration, then to make everything work without issue. So we have engaged with Intel, Nvidia, and partner within the robotic ecosystem to enable these SDKs. Regarding to Intel, we have OpenVINO for AI inferencing, one API for heterogeneous computing, and the RealSense SDK for 3D vision or SLAM. Besides, the core of robot, ROS and the ROS2 are also integrated. And as for Nvidia, we have also the ISAC SDK that is validated together with our platform. Then we work with the partners to sort out the suitable components and integrate the essential software components to build up the robotic kits based on the either Nvidia or Intel platforms, which includes the necessary parts to speed up the development cycle for robotic application up to the use case level or application level. So I believe till now I have given you the general picture about the AMR solutions AAEON has and the market perspective and the benefits of it. So now I'm gonna pass the ball to my colleague Daniele to take you dive into the software part, which bring every piece together in the AMR solutions. Okay, so that's my part. So I will hand to Daniele for a more detailed introduction regarding to software part. Thank you.
Thanks, Owen, for your introduction. I'm Daniele Cleri, software architect at AAEON Europe, and I'm going to showcase first how the Nimbus cloud software platform works together with our robotic development kit powered by Nvidia. One of the robotics development kits we have is based on Nvidia, and Nimbus is a powerful tool that provides you a convenient web user interface to configure, simulate, manage, and control your robots, specifically your robotic development kit from AAEON. In this video, I want to show you how it's possible to add a LiDAR sensor to your robot. So you see here from the web UI, you can select a new sensor and adding the sensors specifically to the robot. You can position it in the right height and within the robot itself so that it can be used by the software. Here we can adjust it manually using the convenient web user interface. And once done, you can see the robot leveraging the LiDAR, the new LiDAR sensor added in the simulation environment. In the other slide here, we are going to showcase the online visualization tools. Here you can see how you can remotely control and manage your robots with Nimbus, where you can assign a new mission, in this case, navigating from A to B, with obstacle avoidance. The robot includes both a LiDAR and a real sensor. Thanks to the Nimbus integration with Nvidia and ISAC SDK, the ROS2 deep learning components can leverage the GPU acceleration on our device for AI inference application and also for other tasks performed by the robot. As mentioned earlier, with Nimbus, we have a convenient web user interface to configure the various aspects of your robot. And for example, here we can add a new algorithm to our robot, in particular the exploration algorithm. And we can link first the camera sensor to the robot, and then add here the new exploration algorithm to the rest of the robot's software stack. And then once the component is available in the web user UI, connect the variables, the input variables and the output variables to the rest of the robot software so that we can, once completed, deploy the solution directly to the robot. Our robotic development kit powered by Nvidia supports the Nvidia ISAC SDK thanks to the integration with Nimbus. It is possible to use the ISAC engine to leverage the Nvidia GPU for acceleration of AI tasks and all the other tasks developed and used within the robot. Many ISAC gems are already available and integrated with the Nimbus interface. As you can see here, there is a list of some of the gems available from ISAC SDK. And then, if not added already, they can be easily included with minimal integration effort. To showcase an example of an Nvidia ISAC gem, here we're going to show you how the ISAC follower gem is running on our robot. The robot, while tracking a person, can detect also the poses and action that the person is doing and follow that person, as you can see from this video. You can see the action performed by the person under the left video. And the robot following the person while the person is moving. Another example we want to show here of integration with the ISAC SDK is the use of site and website visualization tools. In particular, website here is shown as integrated within Nimbus. Website offers API that can be used to create variable plots or to visualize data in 2D and 3D renderings. In this case, you see the 3D of the 3D visualization of the room with the visual odometry of our robot. In our robotic solution, we also have a platform based on our Up series product powered by Intel technology and the Intel Edge Insight for AMR software development kit. In this simple diagram, we can see the hardware setup of our Up robotic development kit. On the left side, the motor control board is based on STM32 microcontroller, is connected to 4 EWM motors, an IMU sensor and battery, and it communicates via UART over USB with our main compute unit that is powering the robot. The kit we provide comes in 2 flavors. One is based on the UpSquare 6000 single board computer powered by Intel Atom 6th generation system on chip, and on the higher performance we have also the solution based on UpExtreme i11 powered by Intel Core i11 Gen system on chip. And the Up robotic development kits come preloaded with Ubuntu Linux operating system, specifically 2004, and the Intel Edge Insight for autonomous mobile robots software development kit. The SDK offers containerized software packages for sensor data ingestion, classification, environment modeling, action planning, and action control. Looking at the software stack, we can see that the SDK is based on the robot operating system 2, ROS2. It also includes OpenVINO toolkit, Intel API 1 base toolkit, Intel RealSense SDK, and other software dependencies, all running from a container, alongside with the source code and reference algorithms and deep learning models as working examples. In addition to autonomous mobility, this package showcases map building and simultaneously location and mapping loop closure functionality. AI workloads are run on the integrated GPU of the robot main compute unit or on Intel Movidius MirrorX accelerator. As you can see, the platform is based on standard Linux operating system with standard Linux driver. The main applications available where to start with the robotic development that are included in the SDK are the fast mapping, which helps to generate 3D map of the environment from the included RealSense 3D camera, including providing the position of the robot. The main application is the Wandering AI application, which combines the middleware software and algorithms to move the robots around the room with obstacle avoidance and local mapping generation in real time, all together with AI object detection. At last, we also have a Gazebo robot simulator application to rapidly test algorithms, design robots, perform regression testing, and train AI system using realistic scenarios. Included in the SDK documentation, there are also other tutorials from basic ROS2 tutorials, GStreamer pipelines, OpenVINO sample applications, One API sample applications, and so on. Here you can see an example of the AirBeads visualization tool with our robot, and on the right, the ROS2 nodes and their interaction with the control the robot. You see the way they communicate with each other and how the robot is able to move thanks to ROS2 and the integration performed within our robot. All the information can be found on the documentation of the Wandering application with our robotic development kit directly on the Intel website. And this is all about our robotic development kits. Thanks.